Okay, we are at the end of the course, and so this is the final exam preparation. So this test was put into Canvas, and so you were to have a go through it on your own first. So question 1 really is a question that we first ran across in Math 100. Find the domain and range of this function. We have a function that's in, they just give us a formula. So the domain, if we remember from Math 100, is the set of allowable x values. So x values that are allowed. And of course, we're just looking at the set of real numbers. Now, if anything is excluded, it's because there's a restriction. Where do we have restrictions? We had restrictions on a fraction. You can't have 0 on the bottom. We had restrictions on a square root. You can't take the square root of something negative. We had restrictions on logarithms. You can't take a logarithm of any base of something negative. That's not the case here. There are no restrictions whatsoever on x. X can be anything and it won't get us into trouble. So x can be any real number. So x can be from negative infinity to positive infinity because there's not any x value that will get us in trouble. Now what about range? Range is the y values that are allowed. And again, we're talking about the real numbers here. So we have a formula for y. And what kind of number will y be? Well, first of all, let's take a look at this. I've got something squared. So something squared is always going to be greater than or equal to 0. So what I have circled there will always be something that's either equal to 0 or a positive number. So it will never be a negative number. So what's the smallest y can be? Well, the smallest that this number can be is 0, and then I have plus 3. So y is greater than or equal to 3. And so that's going to give me my range. And that matches up with selection A. Now, another way to do this would be to put this in our graphing calculator and decide from the graph what the domain and range is going to be. So let's do x plus 2 all squared plus 3. And if I do a zoom 6, then I can get that window a little bit better. Okay, so what is the domain? The domain is how wide the function is, and using the x-axis like a tape measure to measure how wide it is. And of course, this is going to keep going that way forever. That's going to keep going that way forever. So if I'm using the x-axis to measure how wide this thing is, it goes from negative infinity to positive infinity. So my domain is negative infinity to positive infinity. The range, I look at the y-axis. I use the y-axis to measure how tall it is, and I go from lowest to highest. Lowest is here, and that corresponds with y equals 3. And there is no highest point. So the range goes from 3 to infinity. Okay, so that's another way we could have done that. All right, now we're meant to graph this, and so as long as you put it in your calculator correctly, we don't even have to think about it. It just says to graph it. So let's start with a zoom 6. Okay, and we can see that it is a parabola and it opens down, and the vertex is just above the x-axis here, and that's going to be the only one that matches it. So that was just a matter of putting it in our calculator and looking at it. Okay, number 3, the table shows the length in inches and the weight in pounds. Why? For core samples, assume that the relation between x and y is linear and use a graphing utility to find the regression line. Okay, so what I have to do is put the x values in a list and put the y values in a list. I'm going to press stat and I'm going to make sure I've got 2 lists cleared out. So second one, oops, press enter first, sorry. So which list do I want to clear? I want to clear out list 1, comma, and list 2. So if they're already empty, that's okay. So I press the stat, then I press enter, and I put my x values into list 1. And be very careful here, because 99% of the mistakes are made because you make a mistake in entering the data. You don't get the data right. Okay, and just quickly check. So go back through backwards, 73, 67, 61, 55, 49, 43, and 37. And now for list 2. Be really careful here because it's going to be easy to make a mistake here. All right, and I'm going to go back through. So I'm just reading them here off the bottom as I'm scrolling up. And it didn't take long for me to do this, and I know I've entered my data correctly. So now to get the regression line, I press stat, I go to calc, I come down here to number 4, and I'll tell it use list 1 for x and use list 2 for y. And it's giving me the regression line. So the regression line is y equals a, but a I'm going to take to, I'll take it to 3 decimal places to be sure. So 4.936 times x plus b, which is 10.323. Now, what is the expected weight? What is weight? The weight is y. So what is the expected weight? They're telling us to find y for a core sample of this type of rock with a length of 64.15 inches. What is length? Length is x's. So the problem is asking us to find y when x is equal to 64.15 using the regression formula. So my answer is going to be y equals 4.936 times x, which is 64.15, plus 10.323. Now I'm going to put that into the calculator. 4.936 times 64.15 plus 10.323. Now, this is taken to 4 decimal places. All of these answers are taken to 2 decimal places. If I round this to 2 decimal places, so I'm going to write 326.9674 And if I round to 2 decimal places like all of these answers are, that's going to be 326.97. Okay. All right, number 4, use synthetic division to perform this division. I have this rational expression here. So I want the polynomial on the top divided by x minus 6. It's x minus the number in the box. And here I have 1 times x to the 4th, minus 4 times x cubed, minus 9 times x squared, minus 17 times x minus 6. And all the powers of x are accounted for. So I add. 2 times 6 is 12. I add those two together. 3 times 6 is 18. And if I add, I get 1. And 1 times 6 is 6. And if I add, I get 0. So that's my remainder, which tells me x minus 6 is a factor of this polynomial. This is my quotient. So this is going to be my answer. And I start here where the line is. That's a constant. I get that times x, 2 times x squared, and 1 times x cubed. So I keep going with the powers of x till I reach the end. So the answer is going to be 1 times x cubed plus 2 times x squared plus 3x plus 1. And that is matching up with B. Okay, express f of x in the form as x minus k, so that's divisor times quotient plus remainder. So it's x minus k, so that's going to be x minus negative 2 times q of x plus r. So that's going to be x plus 2 times q of x, the quotient, plus r. Okay, so that's what we're going to look for, and that's what we have in all of those. So I'm not able to eliminate anything yet. So it's x minus k is what goes into the box, and k goes in the box, and so k is negative 2. And here I have 1 times x cubed, negative 1 times x squared, but then I have 0 times x, and then I have the constant of 4. So if you did 1, negative 1, and a 4, you left out that 0 placement. So I multiply here and I get that. I add, multiply those two together and add, and then 6 times negative 2 is negative 12, and if I add, I get negative 8. So this is my remainder. That is my quotient. So here's the bar. There's my constant term, my coefficient for x, and x squared. And so this will become x plus 2 times the quotient, so x squared minus 3x plus 6, plus the remainder, so plus negative 8, which is minus 8. And that is matching with selection D. Use the remainder theorem and the synthetic division to find f evaluated at k. Now, this is a multiple choice exam, and you are not required to show your calculations. You don't have to do the method they tell you to do. If k is 3 and I want to find f of 3, I can just plug in 3 for x. And get negative 3. But, okay, let's do it the way they said, use synthetic division. So k goes in the box. And here I have 1 times x squared minus 3 times x, then minus 3. And from the remainder theorem. The remainder theorem says f evaluated at the number in the box is equal to the remainder. That's why it's called the remainder theorem. Okay, so either way is fine. Give all possible rational zeros for the following polynomial. Well, we have to use a rational zeros theorem. So the rational zeros theorem, the possibilities for P are going to be the factors of -7. And 7 is a prime. The possibilities for Q are going to be the factors of the leading coefficient. Then all possible rational zeros is going to be every fraction I can form that has the form P over Q. So that's going to be, well, if Q is plus or minus 1, I'm going to have plus or minus 1 over 1 and plus or minus 7 over 1. If Q is plus or minus 7, then P over Q will be plus or minus 1/7 and plus or minus 7/7, which is plus or minus 1. That's already in my list. And finally, if Q is plus or minus 14, then my possibility for P over Q is going to be plus or minus 1/14 and plus or minus 7/14, which reduces to plus or minus 1/2. And now I'm done. And so now I've just got to try and find which one matches these. So I've got plus or minus 1, I've got plus or minus 1/2, plus or minus 7, plus or minus 7/2, no. Oh, sorry. For 14, I'm leaving out a plus or minus 2. So plus or minus 1, plus or minus 7, plus or minus 14, plus or minus 2. Yeah, so my list wasn't finished, my bad. So plus or minus 1/2, but it's already in my list, and plus or minus 7/2. Okay, now I'm done. Phew. Okay, so let's try again. First of all, it's not going to be that because that list is too short. I need something that's got every single one of those in it. Plus or minus 1, plus or minus 1/7, plus or minus 2, no. Plus or minus 1, plus or minus 1/2, yeah. Plus or minus 7, yeah. Plus or minus 2/7, no. I have 7/2, but not 2/7. So that should be it. Plus or minus 1, plus or minus 1/2, plus or minus 7, plus or minus 7/2, plus or minus 1/7, plus or minus 1/14. Find the zeros of the polynomial function and state the multiplicity of each. Okay. What is a zero? It's any value of x that makes this equal to 0. So we can see clearly here that -8 is a 0, because if I plug in -8 for x, that's going to make this 0, and so the whole thing will be 0. So -8 is a 0, and its multiplicity is 2. And then if I look at this part of the equation, what will make the whole thing equal to 0? Well, if x is 8, so 8 is a 0, and what is its multiplicity? 3. And there aren't any other zeros. So -8 multiplicity 2 and 8 multiplicity 3. All I've got there. All right, find the domain and range of the rational function graph below. Domain, we use the x-axis to measure how wide it is, and we leave out any graphs. So if the x-axis is like a tape measure, this is going to keep going that way forever. So I'm starting out from -infinity, going up to, but not including -4, because it never touches -4. There's a gap at -4. I have to jump over that gap. Then I pick up the gap when I get to the right of -4, and then using the x-axis as a tape measure to measure how wide it is, it keeps going forever. So that's my domain. Now the range, we use the y-axis to measure how tall. For the range of this one, this is approaching but never reaching the x-axis because we have a horizontal asymptote here at the x-axis. So if I use the y-axis to measure how tall, the range will be, I go from lowest to highest. Well, the lowest, it doesn't reach 0, so we're going to start just above 0. But once I have that, I always have points on this going up forever. So for the domain, use the x-axis to measure how wide. For the range, use the y-axis to measure how tall. And this is the one that matches. Now, use a graphing utility to approximate the real zeros of 3x cubed plus x squared minus 9x minus 3. Okay. So what we want to do in here, well, first let's turn this on. Let's clear out anything old, and I want to put this in my calculator. And let's just take a zoom 6. Okay, and now let's zoom in on that. Let's see if I just change it to that. I'm going to get any. Okay. So I have real zeros at the x-axis. And let's see if I can do a little bit better. Okay, so here's -1 and there's -2. So I'm going to have a real zero either at -1.7 or -1.8. Okay, so I can use my calculator to see where these are. So I'm going to press second table. No, I'm going to press second and trace because I want the calc. And I want to come down here to 0 and press enter. Now, let's see if we can find out where that 0 is. But I have to tell it a left bound. I have to find somewhere on the graph that's to the left of where I'm pointing. So with my cursor, notice how I'm going to move that until that is to the left. So just underneath where that 0 is. So I'm going to go with that as a left bound, so I'm going to press enter. Then it's asking me where's a right bound from this 0. So I'm going to go to the right on the graph. And so here, the 0 is here, that's to the right, so I'm going to press enter. Then the calculator is asking me, do you want me to guess what the 0 is? So yes, I do. Okay. So it's telling me that I have a 0 at -1.732051. Okay, so if you have to decide between -1.8 and -1.7, we're going to go for -1.7. So that's one of my zeros. So it's not going to be that. It's not going to be that. It's going to be one of these. Okay. And what else? Now, I should be able to decide now. I don't have to do anything else. Because this says I only have one -0, and the other two zeros are positive on the right side of the x-axis, but that's not true here. This 0 is going to be negative. So the only thing that is left for it to be is that. And again, we could do the calc and Now to get this second 0, I get a bound just to the left of it, get a bound just to the right of it, then ask it to guess, and it's giving me negative 0.33333 is the 0. Okay, so, but we should be able to tell once we've gotten to that. Okay, horizontal asymptote. Well, the degree of the top is 2, the degree of the bottom is 2. So if they have the same degree, there is a horizontal asymptote, and it is the line y equals, the horizontal line y equals leading coefficient of the top divided by leading coefficient of the bottom. So it's going to be the horizontal line y equals 2. Get the equation of the oblique asymptote, if any. Well, the degree here is 2. The degree in the bottom is 1. So the degree of the top is 1 more than the bottom. We do have a slant asymptote or a oblique asymptote. So we have to use synthetic division. So the last 3 problems on the midterm had this in them. So it's x minus a number. It always has to be in that form for you to use synthetic division. So x minus the number in the box. And then I have that. So if you put a positive 9 in that box, your answer is wrong. That gives me that. If I add, I get negative 18, and I'm done. Because for oblique asymptotes, it's y equals the quotient. So I don't even need to know the remainder. This is the quotient. There's the bar. There's my constant. There's my coefficient for x. And so my answer is y equals 1 times x plus negative 18. That's my answer. All right. Decide whether or not the functions are inverses of each other. Okay, so let's start with this guy. What is the process? The process is you rewrite f of x with a y, then you swap x's and y's, then you solve for y. So what I'm going to do is I'm going to multiply both sides by y plus 7. So they will cancel here, and I'll just have 1, and then over here I'm going to have that. So now I multiply this through, xy plus 7x equals 1. Now, if I'm going to solve for y, I got to get y by itself. So subtract 7x from both sides. And now divide both sides by x to get y by itself. So I have y equals 1 minus 7x over x. And so that is what my inverse is, because I've got y by itself. This is a correct answer. Now, looking at what we have here, I can put that first. Or I can split this up. And then those would cancel. So all of these are the same inverse function. And I can see that that is not what's happened here. It's off by a negative sign, so the answer is no, they're not. Sketch the graph of the rational function. Well, you can put this in your calculator as long as you do it correctly. Remember, it's going to be 4x, then the division key, but then you've got to put the entire denominator in parentheses. And if you don't supply those parentheses that I've marked in red, you get the wrong thing. So it's an easy one to do. Just by putting it in your graphing calculator, as long as you put it in correctly. So 4x, hit the division key, then red parenthesis, then x plus 4 in parentheses, then x plus 2 in parentheses, and then you have to supply that right red parenthesis, and then do a zoom 6. Okay, now on the zoom 6, we might not be seeing enough there, so let's just increase the y. So instead of from negative 10 to positive 10, let's see what happens there. Okay. So that, after I've increased that limit there, is most definitely matching with selection D. Okay. So don't trust the standard window. Okay. How did I know to expand that? Because look at this guy. Where does he start? Well, there's 12. And the standard window only goes up to 10. So this guy wasn't showing up. All right. So you got to be really careful about those things. Same thing with this guy. He wasn't showing up in a standard window. All right. Determine whether or not the function is one-to-one. Well, yes, it is. It passes the horizontal line test. This doesn't touch it at all, the x-axis, but any horizontal line I care to draw only comes into contact with it at most once. Decide whether the given functions are inverses. Well, how do you decide? If AB is a pairing in F, then if I swap the coefficients, it lives in the inverse. So yeah, yes, and yes. So if there'd been any pairing that didn't have it swapped in either one of them, I would have said no. Find all complex zeros of the polynomial function, give exact values, list multiple zeros as necessary. Okay, what we need to do with this one is put it in the calculator first, because real zeros will show up as x-intercepts. So clear this out and do x cubed minus 3x squared minus 5x plus 39. And let's start with the zoom 6. Okay, so we do have a 0 at -3. And how do I know it's -3 exactly? Because -3 is in all of my selections, okay? So I do know that much. And I don't have anything to narrow these down at this point. -3 is a 0, that's for sure. So -3 is a 0, tells me that x minus -3 is a factor. And I'm going to come out with this being, let me do it down here. Let me do it over here. I can use synthetic division to break it down. So I can write this as the divisor, which is x minus the number in the box, x minus -3, times the quotient. That's the quotient. X squared minus 6x plus 13. Okay. So one of my zeros is -3. What are my other zeros? I use the quadratic formula. So my other zeros are going to be -b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. So I have 36 minus 52, all divided by 2. So the square root of -16 is 4i. So I get 3 plus or minus 2i. Those are my zeros. So all of my zeros together are -3, comma, 3 plus 2i, and 3 minus 2i. Those are my zeros. There we go. That matches. Find the indicated matrix. That's C, find a half times C. From what we've done in class, that would be a half times 6, a half times -2, and a half times 8. Half times 6 is 3, a half times -2 is -1, and a half times 8 is 4. So 3, -1, and 4. Solve the equation. That is an exponential equation, and so we need to do a conversion. Okay. So what is my conversion formula? That is the same thing as that. So here's my A, here's my Y, there's my X, and then go from red to black. So it's going to be log taken at base 1/4 of 256 is equal to the black X. And if my calculator only does logarithms in base 10 and base E, so using change of base formula on this, that's the same as log of 256 over log of 1/4. So that's one way I could have done that. So log of 256 divided by log, common logarithm of 1/4, which gives me -4. That's one way I could have done that. Another way I could have done that, well, 256 okay, so all right, so I must have pressed a freeze button. Okay, so I don't know when I pressed the freeze button. Oh dear. So one way I could have done that was to do the conversion formula in red. And X is equal to that exactly. I can't take a base 1/4, a logarithm in that base, so I use the change of base formula, and I got that. Another way I could do that is if I write it like this. 4 is the same thing as 2 squared. That's the same thing as that. And of course, 1/2 is the same as 2 to the negative first power. So that is the same as 2 to the negative 2x, because I multiply those together. Now, what about 256? I think that's 2 to the 8th power. I think. Yeah, 256 is 2 to the 8th. Now the bases are the same, and so the exponents are the same. That's the uniqueness property. And so the only way for this to be true, I divide both sides by -2, and x is equal to -4. That was another way to get that. Okay. Find the future value. Okay. And they gave us the formula. Wasn't that nice of them? Okay, so that's how much we start with. So that's our P. That's how long, so that's T. 4%, that's telling us that R is 4 divided by 100. So this will equal P times 1 plus 0.04 monthly means N is 12 to the power of N times T. Okay, so that's what I have to put into the calculator. 3443.61 in parentheses 1 plus 0.04 divided by 12, close parentheses, to the power of, in parentheses, 12 times 11, close parentheses. Okay. So in dollars and cents, we have to round it to 2 decimal places, and that becomes that. Graph the exponential function using transformations where appropriate. Again, this is a multiple choice exam. You're not being marked on your work. You just have to circle the right thing. So just put your graph, use it, your graphing calculator. Put that in your graphing calculator and look at it. Okay, so 4 to the power of x minus 1. Then do a zoom 6. Okay, now this one has this part of the graph being under the x-axis, and that's what's going on here. So definitely got to be a. Solve this equation. Well, use the conversion formula. So there's our A, that's our X, and that's our Y. So A to the red Y is equal to that. Okay. So that's not too bad if we remember that 5 cubed is 125. All right, 5 squared is 25, and 5 cubed is 25 times 5, which is 125. So I can rewrite it like that, which is the same as that, which is the same as that, which is the same as that. So this is equal to that. The only way these can be the same is if the exponents are the same, because the base is the same. So x is equal to -3. Okay, give the domain and the range. Okay, graph it. Now you might say, well, my calculator won't do it in base 2. It only does it in base 10 and base E, LOG and LN. Well, use your conversion formula. So using the conversion formula, we have that. And now let's look at the darn thing in our calculator. So I'm going to have the common logarithm of x plus, oops, it provides the parenthesis. Common logarithm of x plus 4, close parentheses, divided by the common logarithm of 2. And then do a zoom 6. Okay, so the only one that's going to resemble is this guy. Now you're saying, where's the tail? Well, this is a vertical asymptote here, and so what happens is your calculator cannot do infinity. And since we have an asymptote here that I'm drawing in red, that's getting closer and closer and closer, but never touches x equals -4. And so it can do it for a while, but then it's taking it to 9 decimal places, our calculator, and after that, it's just saying, well, it's the same thing. And if you have 2 on top of each other, then it's not a function anymore. So it can't do infinity, it cuts off there. But it has to be that one. It doesn't even remotely resemble any of the others. Number 24, use the change of base rule to find the logarithm to 4 decimal places. Okay, so that's the same thing as, I always use the common logarithm, but you can use the natural logarithm if you want. But the thing is, you have to use both, you have to use the same thing in top and bottom. So it doesn't matter. The rule works for either one of those. I just automatically do log. So 295 divided by log of 5.1. Okay, and there's only one thing it could be, and that's D. Use the product, quotient, and power rules of logarithms to rewrite the expression as a single logarithm. Okay, so we have to use our 3 logarithm rules. This is rule number 3, because you see the plus sign there? If you try and put those together using rule 1, you've messed up the problem. You can only use rule 1, put them together, if there's nothing out the front here. So I have to use rule 3 on both of these. Now that there's nothing out the front and there's a plus sign here, I can use rule 1 and put them together. And using rule 1, it's this times that. Okay, and so that's matching up with that one. All right, right in logarithmic form, we've got to remember our conversion formula. So this is my A, that's my red Y, that's my red X. So I'm going to have logarithm of, the base is the red A, the red X is that, and equals the red Y. Okay, that is matching up with that one. Okay, solve the equation, express the solution in exact form. So no approximations is what that is saying. Okay, I'm going to put these together into one logarithm using rule 1. So using rule 1, I'm going to have negative x times 4. The natural logarithm of negative x times 4. Negative x times 4 is negative 4x. Now I'm going to use the uniqueness property for logarithms. I have single logarithms on each side, nothing in front of them, so their arguments are the same. So now I can get rid of these and just say negative 4x equals 3x minus 9. I can only do that because I have single logarithms on each side. If I only had that on one side and a logarithm on this side, I couldn't do it, even though I've seen some students say that. No. Single logarithms on both sides, then I can say the insides are the same. So how about I subtract 3x from both sides? So that tells me negative 7x is equal to negative 9. And now to solve for x, I divide both sides by negative 7. And so this tells me x is equal to negative 9 over negative 7. The negative signs cancel, and I have 9/7. And so my answer is A. Solve the equation. If necessary, round to the nearest thousandth. Okay. Before I can do the conversion, it's not in the form to do the conversion because I don't have something by itself to a power. I have 8 times something to a power. So the first thing I have to do before I do a conversion is divide both sides by 8. So this becomes that equals 9/8. Now I can do the conversion. There's my A. There's my y, there's my red x. And so this becomes the logarithm of base e of the red x equals the red y. So this is saying that the natural logarithm of 9/8 equals 7x plus 5. Now I have to solve this for x, so I'm not done yet. How do I get x by itself? Well, let's subtract 5 from both sides. I'm not done yet. How do I solve this for x? The next thing is to divide both sides by 7. So all of that gets divided by 7. So this is what x is equal to. That is my exact answer. So what is that approximately? I have to put that into the calculator. Let me clear this. So my numerator is natural logarithm of 9/8 minus 5. Then I press enter. That's my numerator. All of that divided by 7. So that is going to be my answer for x. And that is matching up with selection C. Okay, number 29. How long will it take a sample of radioactive substance to decay to half of its original amount if it decays according to this function, where t is the time in years? Okay. So, how much did we start with? Well, this is the amount that you start with. And if you can't remember that, when does your time start? When t is equal to 0. So a of naught is your starting time, and that would be 250 times e to the power of, well, 0, because it's negative 0.121 times 0, and e to the 0 is 1. So we want to find t when a of t is equal to half of 250. And what is 250 divided by 2? What's half of that? 125. But we have a formula for A of t. So you put these things equal to each other and solve for t. So I'm going to do that over here. All right, so I'm going to divide both sides by 250. So that reduces to a half. The 250s cancel there. And now I have an exponential equation that I can convert into a logarithmic equation. So a to the y is equal to x. And I can convert that into logarithmic form. So I have log of base e of the red x is equal to the red y. Now I need to solve this for t, which means I have to divide both sides by negative 0.121. So what we get here is t equals, well, the natural logarithm of a half divided by negative 0.121. That is my exact answer. And now let's see what that is in the calculator. So the natural logarithm of a half, close parentheses, divided by the negative of 0.121. So that was my exact answer. And when I put that into the calculator, it's coming up with selection B. Okay, number 30. This says to solve by substitution. You can do that if you want. This is an exam. You are only judged by your multiple choice answers. You can use any method you want. So how about we do it using matrices? So I'm going to call the augmented matrix A, and the augmented matrix is going to be that, and I'll do Gaussian elimination by doing rref on that. So this has 1, 2 rows and 1, 2, 3 columns. So I've got 1, 4, negative 26, and the second row is 4, 4, negative 20. Enter. Then I have to get out. I have to get back into the matrix menu, go to Math, and go down till I find rref. I'm back on the main view screen. I have to tell it what matrix do you want me to do rref with. The matrix that I defined is A. So under names, I just have A there. Okay. And so now what this says is x times 1 plus y times 0. So x equals 2. And 0 times x plus 1 times y is equal to negative 7. So where I drew that line there is where the equal sign goes. So the point x comma y is going to be 2 comma negative 7 is my answer. All right, use the given row transformation to change the matrix as indicated. Well, just do what it says. You want to take negative 6 times row 3. You want to take that and add it to row 1. So the only row that's going to change is going to be row 1. Okay, negative 6 times row 3. So negative 6 times this number is negative 6, and add that to the current row 1. So 6 plus negative 6 is 0. Negative 6 times this number is negative 6, and add it to that number. Negative 6 plus 5 is negative 1. Negative 6 times that number is negative 12, and add negative 12 to that number and you get 0. Okay, so that's going to match up with that guy. Write the augmented matrix, do not solve the system. Okay, so that is very easy. We just have the coefficients, and I'm just making sure everything's lined up right, which it is. All the x's and whatnot are together, and our line goes where the equal sign went, so straight away it's not going to be that. So I need to have negative 3, 23, and negative 3 to the right of the line, so it's not going to be that. And negative 2, 3, and 5. Negative 2, 3, and 5, that does not match. All right, so it's not going to be that. So everything else matches. Find the value of the determinant. Use your graphing calculator. So define that matrix. So get into the matrix menu, go to the editor, and let's call it A. And I've got my old matrix A there, but I'm defining a new one. I need to tell it what are the dimensions. How many rows? 1, 2, 3. How many columns? 1, 2, 3. So it's going to hang on to what remnants of the old matrix are there that fit in the dimensions of the new one. Now, put your entries in row by row. So I have 3. So I'm just writing over 2, 1. Then it automatically puts me on the second row. 5, 2, 3, and then 3, 2, 4. Enter. Now I have, okay, what happened there? I didn't do an enter. So I have 3, 2, 1, 5, 2, 3. Enter. And then 3, 2, 4. Okay, because I'm trying to enter all this in with a mouse, and I don't have the actual calculator in front of me, so just want to be really careful. So I'm just double checking. Okay, that looks good now. So get out of the matrix menu, get back in. Go to math, and there you are, determinant. Press enter. Now, your calculator is asking you take the determinant of what? The determinant of the matrix that I named A, and close parenthesis. So negative 12. There we are. Give all solutions of the nonlinear system of equations. Okay. For this one, let's do elimination as it is. Add these two together. So x squared plus x squared is 2x squared. Y squared plus negative y squared, that's eliminated. So I have 2x squared equals 40 plus 40 plus negative 32 is going to give me positive 8. Divide both sides by 2, and you have x squared equals 4. What are the solutions to that? The solutions are x equals 2 and x equals negative 2. So what happens if x equals 2? I go back to one of my formulas. It doesn't matter. So the first one, if x equals 2, that becomes 2 squared, which is 4. If I subtract both sides, I get y squared equals 36. So what are my answers for y? Y is equal to 6, or y is equal to negative 6. So in this case, I have two answers. I have the point 2, 6, and I have the point 2, -6. Have two answers there. Now over here, if x is -2, again, I can pick either one of those formulas. It doesn't matter. So if I plug in -2 for x, -2 in parentheses all squared is also +4. And again, I get y squared equals 36 if I subtract 4 from both sides. So y is equal to 6 or -6. I get two more points. I get an x coordinate of -2 and a y coordinate of 6 or a y coordinate of -6. So I have 4 points here. So, and be very careful, look how confusing this is. 2, 6 and 2, -6. Yeah. And -2, 6 and -2, -6. That is the one we need. Not this one, because they've swapped their x's and y's, and you can't do that. Okay, moving on to number 35. So we have an objective function here, and they want the maximum value. So I'm going to write this objective function as z equals 2x plus 4y, and z just means this is a function of two variables. So when you see it on the final, it would either be written as objective function or z. Rarely do they write it like this, but this is what we actually want. And I'm going to use the corner points that have been given to me. So, and then which one is the maximum? So if x is 1 and y is 1, I'm going to get 2 plus 4, which is 6. Then I move on to this corner point. So x is 3 and y is 8. So 6 plus 32 is going to give me 38. Then the function becomes 2 times 6 plus 4 times 11. So that's 12 plus 44. And then I have 7 and 4. And this becomes 2 times 7 plus 4 times 4, which is 14 plus 16, which will be 30. And so my maximum is 56. Now, look at that. So more often than not, students that have no idea how to do this just circle the maximum and they get it wrong. They want the maximum for this function, and it's 56. Okay, perform the operations when possible. Now, this is a lot quicker than putting it all in your graphing calculator. This is a 3 by 1. This is a 3 by 1. It will work, and we'll get a 3 by 1. So I'm not going to have that, and I'm not going to have that. And what will go here is 3 plus -5 is -2, and already I can say it's got to be that one. -1 plus 4 is 3. -4 plus 5 is 1. Find the matrix product if possible. This is a 2 by 2. This is a 2 rows and 3 columns. So the inside numbers are the same, so it will work, and we get a 2 by 3. So 2 rows and 3 columns. So it will work. So I can eliminate that one. And this is a 1, 2, 3. That's a 3 by 2. So we know it's not going to be that. And again, I can probably do it quicker. What's going to go here? Row 1, column 1. Well, it's going to be -1 times 0 plus 3 times 1. So 0 plus 3. And so I know that that corner, top corner, has got to be a 3. So that was quicker than doing it in my calculator. All right, graph the solution set of the system of inequalities. I have to rewrite these with y on the left-hand side. So I'm going to subtract x from both sides here. That does not change the direction of the arrow. Then I'm going to divide everything by 2. And dividing by a positive number does not change the direction of the arrow. Here I'm going to subtract x from both sides. That will not change the direction of the arrow. 0 minus x is just negative x. But to get y by itself, I have to negate both sides, or multiply both sides by -1. Multiplying both sides by a negative sign, or negating, changes the direction of the arrow. Okay, so the line y equals x, I'm going to start with that one, is this line. And I want everything on or above this line. Then I need to see what the line 1 minus x over 2 looks like. And I'll do that in red. So let me clear that out. 1 minus x over 2. And do a zoom 6. And if I want to get some points, do second graph. I know that 0, 1 is on there. I know that 2, 0 is on there. And if I just scroll up, I know -2, positive 2 is on there. -2, positive 2, 2, 0. Oh, and 0, 1. That's that one. All right, let's try that again. So I've got highlighted -2, 2, then 0, 1, and then 2, 0. All right. And I want on the line and above. So I'm looking for the one that's got this overlap range. Okay, and that's going to match up with this one. That is matching up with C. Okay, find the inverse if it exists for the matrix. Okay, this probably is easy enough to do in the calculator. So into the matrix menu, to the editor. This is a 2 by 2. And I've got -6, -3, then 0, then 5. And let's get back into the matrix menu. Let's select this. And let's ask it for the inverse. Now, if I want to see that in fractions, I do math, enter, and enter again. So I've got -1/6, -1/10, 0, and 1/5. Okay. Okay, partial fraction decomposition. This is from a previous year. This is not in the current list of topics. Okay, so you don't have to worry about partial fraction decomposition. If you had to do this in a snap, if you were going to put these into one fraction, what would they look like? So I have to have that in the bottom. And so here you'd have to multiply top and bottom of this one by x plus 3. And here you'd have to multiply top and bottom of that one by x minus 2. And so I'd have x minus 7x, which would give me a negative 6x for this one in the top, and so it wouldn't be that one. If I was trying to get the same thing in the bottom there, I'd have to multiply top and bottom of this one by x minus 2. And I'd have to multiply this top and bottom of this one by x plus 3. And so I'd have 7x plus x, which would give me 8x in the top here, and that's not what we have there. Here I'd have to multiply top and bottom of this one by x minus 2. And here I'd have to multiply top and bottom of this one by x plus 3. And I'd have 6x minus 17x, which would give me negative 11x in the top, and that wouldn't work either. So it wouldn't be that one. So if I was putting these together into one fraction, top and bottom of this one, I'd have to multiply by x minus 2. Top and bottom of this one, to get it into one fraction, I have to multiply by x plus 3. And so I'd have 7x minus x, and then negative 14 minus 3, and so it'd be the last one there. But it wasn't in the current list of topics for summer 2017. Find any vertical asymptotes. We want real zeros of the denominator. So real zeros when it's in lowest form. This is in lowest form because there's nothing to cancel. So my zeros are 8 and negative 7. So I will have two vertical asymptotes. The vertical line x equals 8 and the vertical line x equals negative 7. Find all complex zeros of the polynomial function, give exact values, list multiple zeros as necessary. Okay, all of these have negative 4 as a zero. All of them do. So I know negative 4 is a zero. So I can use that in synthetic division. And I can get the rest of the zeros this way. Now don't forget, so it's 1 times x cubed, negative 2 times x squared, minus 11x, and then 52. So we don't have a zero placement there. So all powers of x are represented. 4 gives me positive 24, 13. And 13 times negative 4 is negative 52, which is 0. So this is equal to x minus the number in the box, which is x plus 4, times the quotient. There's the line. So constant x and x squared. So x squared minus 6x plus 13. So I know the zero here is negative 4. To find the zeros of that, I use the quadratic formula. So it will be negative b plus or minus b squared minus 4 times a times c, all over 2 times a. So I will have 6 plus or minus 36 minus 52. So 6 plus or minus 4i over 2, which is 6 over 2 plus or minus 4i over 2, which is going to be 3 plus 2i and 3 minus 2i. There we go. Identify the vertex of the parabola. Well, just put it in your calculator and look at it. That's the quickest way. X squared minus 6x plus 10. Do zoom 6. All right, and let's just change the window. Okay, so there's our vertex, and that is at the point 3, 1. Okay, so if the following defines a one-to-one function, find its inverse. If not, write not one-to-one. Okay. So first of all, is it a function? Yes, because there's no repetitions of the first coordinate. Is it one-to-one? No. It's not one-to-one because I do have repetition in the second coordinates. It's not one-to-one. So there will be no inverse. For the function as defined that is one-to-one, graph f and f inverse on the same axes. Okay, first of all, what does the square root of x plus 5 look like? Well, that's the square root of x. I'm replacing the x with x plus 5 inside the parenthesis here from the original function. And so that's going to be a left shift. But, you know, you can always put it in your graphing calculator to look at it. So let's get rid of that. Let's see what that looks like. Let me find the square root of x plus 5. And let's do a zoom 6 again. So there is the function, the square root of x plus 5. So this function and its inverse are symmetric with respect to the line y equals x. So that's the line I'm drawing. And to see what that would be, I just turn it up like this and I think, well, what would its mirror image look like? It'd look like that I've drawn in red. And so I just need to find that down here, and there it is. So if this is the line y equals x, these are mirror images of each other. So it's going to be B. Solve this inequality. Okay. When we have some absolute value is less than or equal to a number, a positive number, it becomes, we can sandwich it in by dropping the absolute value symbols. Now I have to solve for x. I've got to get x by itself in the middle. So I'm going to subtract 5 from everything. So down here, negative 7 minus 5, I have negative 12. Those cancel. And 7 minus 5 is negative 2. Now, to get this by x by itself, I need to divide everything by negative 3. But when I do that, it will change the arrow. When you divide or multiply by something negative, it changes the direction of the arrow. So I've got negative 12 divided by negative 3 is positive 4. And now it's going to be greater than or equal to x, which is going to be greater than or equal to negative 2 divided by negative 3 is positive 2/3. So x is between is between 2/3 and 4. Now remember, if you're doing this in interval form, you have to do smallest to largest. So if I want to flip this, then it just is going to flip the signs. And so because of the symbols here, oh, I have 7 minus 5 is a positive 2. Okay, that's my bad, 100%. 7 minus 5 is a positive 2. So I have 2 divided by negative 3. Okay, and so then I get that. Sorry about that. All right, so now I look up at the selections, and there's only one it could be because of the symbol. Equality is included there. 7 minus 5 is positive 2. That was my bad. But it was a negative 3 that I divided by here, so that's what flipped the sign for everything. Okay. Graph this polynomial function. Well, again, all I have to do is put that in my calculator. These are really easy questions. As long as I just put it in my calculator and look. Minus x times 2. And then do as in 6. Now, assuming I've done it all correctly. All right. And let me just do the same to the y. Okay. All right, so that's going through negative 2, then negative 1, and negative 2. Okay, so these kind of had the same shape, and I'm just making sure which one of these two it is by seeing where it goes through the x-axis and where it goes through the y-axis, and that's matching up with C. Solve the system by using the inverse coefficient matrix. Okay, so if A is this matrix and X is XY and B is that, then this system I can write as A times X equals B. Now I want to solve it for X, so I multiply the left-hand side of both of these by A inverse. And you have to do the left-hand side of both because matrix multiplication is not commutative. So those will go away. So I have to solve it by asking my graphing calculator to do that. Okay. So let's get into the matrix menu. Go to the editor, and A will be a 2 by 2, and I'll have 5, 4, 4, and negative 2. Then get out, get back in, go to the editor, and define B. So B is a 2 by 1. So that will be 8 and 22. Get out, get back in, and select A, and then tell it inverse times, back into the matrix menu and select B. And so that is my answer. So the matrix X, which is that, is equal to this. So X equals 4 and Y equals negative 3. So as an answer, as a point, that's what we get, 4 comma negative 3. 49, find the solution if it exists. So I'll use the augmented matrix. Now, this was not, what I want to say before I finish is These are problems that I've put together from previous exams. This was never an actual previous exam, okay? I put this practice exam together on purpose. Notice there were no partial, no piecewise functions in here. There was a lot of stuff that was not on the midterm, that was not on this practice exam, because I wanted to give you guys a lot of practice with stuff that was not on the midterm, because you've already had your practice on the midterm. Do not assume, because there was not a question here on piecewise functions, that there won't be a question of that on your final. There most definitely will. Okay, it is over the whole course. Okay, so let's define this matrix as A, and let's see if we can get our answer. So I'm going to pick A. This has 3 rows and 4 columns. So I have 3, -3, -6, -3. Oops, what happened? Okay, that should be a -3. Okay, I don't know what happened there. Then 2, -2, -4, and -2. Then -2, 3, 1, and 7. Get out, get back in, go to math, go down to rref. So we're going to do Gaussian elimination, row reduced echelon form, and tell it you want to do it with A. Oops. 1, 0, -5, 4, 0, 1, -3, 5, 0, 0, 0, 0. Okay. When you have zeros in the entire row, that means that there are infinitely many solutions. So what does the first row tell you? It tells you 1 times x plus 0 times y minus 5 times z equals 4. Now, there's infinitely many solutions. So I know it can't be those. What does the second row tell you? 0 times x plus 1 times y minus 3 times z equals 5. So now I have to give a general solution. So instead of x, y, z, I have to write with only one letter. So if I add 5z to both sides of that equation, my x is equal to 4 plus 5z. If I add 3z to both sides of this equation, I have y is equal to 5 plus 3z. And then I have z. So I have written the general solution with one letter. And 4 plus 5z, that's the same as 5z plus 4. 5 plus 3z, that's the one I want. Finally, what about this guy? Go same thing, get augmented matrix and do row reduced echelon form. So use Gaussian elimination on your calculator to get it into row reduced echelon form. That's my augmented matrix. So second matrix, 3 times 4. So I've got 1, 1, -3, 4, 2, 1, -1, 2, 3, 2, -4, and 6. Go into math, go all the way down to rref, and do it with matrix A. Okay, and so once again, it looks like we are getting infinitely many solutions. Okay, that's telling me infinitely many solutions. And so I have x plus 0y plus 2z equals -2. 0 plus 1y minus 5z is equal to 6. And since those are all zeros, infinitely many, so instead of x, y, z, I have to have general solution, one letter. So if I subtract 2z from both sides, I have -2 minus 2z is x. If I add 5z to both sides here, so that's the number 6, I get y is 6 plus 5z. And z there. So that should have been a z. That's obviously a typo. So -2 minus 2z, 6 plus 5z, and z. Okay, so that was obviously a typo. Okay, so that concludes this. I wanted to do a few more problems that you might come up across. Look at this one. The following table describes the population of rabbits as a function of time. Use exponential regression to determine the exponential function, which best models the rabbit population. Now, we didn't deal with this specifically, but we did linear regression, we did quadratic regression. Exponential regression is no different. So we're going to put our x values in a list and our y values in a list. We've got to clear out two lists. So my x values are 0, 1, 2, 3, 4. My y values are 20, 26, 36, 53, and 91. Then stat, go to calc. Now we had linear regression and we had quadratic regression. Those are ones we studied. There's also cubic regression, quartic regression. Keep going down. Keep going. There we go. Exponential regression. Use exponential regression. Exponential regression with list 1 and list 2. So I'm going to have 18 times something to the x. So 1.45 to the x. All right, so the closest one that comes to is selection D. That's the very closest one. That's the only one it could be. Okay, so b to the x is 1.45 to the x, and if I'm taking the front to one decimal place, I get 18. There's nothing else it could be in there. Which one of these is not a property of logarithms? Okay, well, we had 3 properties of logarithms. That is the change of base formula for a specific example. That is not. So we have to be really careful. That's change of base. That is rule 2. That is rule 3. That is getting rule 2 and the change of base formula confused. So the answer is B. All right, you use change of base formula for that. Change of base formula for that. do the conversion formula. So if I want to do that, then where's my different colored pen? There's a to the y equals x. That's going to be, oops, that's going to be the same thing as that. And then add 2 to both sides. That's my exact answer for x. Now, if I want to get that on a calculator, I can't take calculations in base 4, so I'll have to use the change of base formula. But that'll be my x. So log of 9 divided by common logarithm of 4. You cannot do log of 9/4. You get the wrong answer. They're not the same thing. Press enter. So that's the answer I get for that. And that's matching up with B. Okay. So I think we're pretty right. All right, what about 34? Well, you have to know your exponent rules for that one, because that's the same as e, the base is the same, so that's the same as e to the power of x minus 3 equals 7. So there's your a, there's your y, there's your x. That's the same thing as that. So the red x is 7, the red y is that. And add 3 to both sides, that's your x. So I just need to get natural logarithm of 7 plus 3, and that will be my answer. So 4.94. Okay, so you have to put those together using rule 1. So that's the common logarithm of x times x squared. So that's the common logarithm of x cubed equals 3. Then change it into exponential. All right, we did a half-life population. So there was one in here. Done all of those. Here we go. Use X to denote the number of boxes shipped to Des Moines, and use Y to denote the number of boxes shipped to San Antonio. Okay, first of all, look at this. This is saying 200 is greater than or equal to 800. That's not true. The whole thing is wrong. You can reject it. And again, there's a false statement. 200 is not greater than or equal to 100. You can reject that. It comes down to these two. All right. They have at most 2,400 boxes of almonds to be shipped from their plant in Sacramento to Des Moines and San Antonio. Okay. The Des Moines market needs at least 1,000 boxes. X was Des Moines, so X is greater than or equal to 1,000. San Antonio has to have 800. San Antonio was X, and so San Antonio was Y, and so Y has to be greater than or equal to 800. So both of those are true. Now, both of those together, you have to have at most 2,400 boxes of almond to be shipped to both of them, at most. So going out to both of them has to be at most 2,400, so less than or equal to. So you just have to take the words and match up the symbols. So there wasn't one like that in the practice one, so I wanted to make sure you guys were able to see that. Okay, we've done that. We've done that. There's no partial fraction questions. Okay. No partial fraction questions. So we used to include partial fractions in the curriculum, but that's been a long time ago. You cannot use rref unless your system is linear. So you cannot use rref for something like that. You would have to use elimination by hand. So if you're trying to put that into a matrix, you will get the wrong answer. So if I try and solve that, well, I would do it by elimination. First of all, I'm going to refine this. So the top one, that's okay. That can be the same. The bottom one, I'm going to subtract 4x from both sides. And then I will add these together. And so when I add those together, I get 0. And I'll have x squared plus 6x minus 4x, because I'm adding these together. Okay. And now you should be able to factor that. Two numbers that multiply together to give you -3, but add up together to give you +2. How about +3 and -1? And now what are the solutions? -3 and +1. So I have x is equal to -3 or x is equal to +1. And now go back to the simpler equation. If x is -3, this tells me that. So if I add 12 to both sides, negative y is 9, so y is equal to 9. So I get a point here, -3, 9. That's one intersection point. Now, if I use the same formula for that guy, and if x is 1, that gives me that. So subtract 4 from both sides. And so if I negate both sides, y is equal to 7, and I get the point 1, 7. So I'm looking for -3, 9, and 1, 7. -3, 9. Oh, so hang on, Here I had -y equals 9, and so if I negate both sides, y is equal to -9. So I'm looking for -3, -9, and 1, 7. -3, -9, and 1, 7. So A. So if you have a system that is not linear, so as soon as one of those has a power that's 2 or more, it's not linear, you cannot use an augmented matrix to solve. Okay, so that really should cover everything. Just don't forget, I purposely chose problems on the practice exam that were not included in the midterm because I wanted to give you more to practice. The final is over the whole course. So don't think because you didn't have any questions that were on the midterm that you don't have to know the midterm. It's the furthest thing from the truth, okay?